Hello, YouTube. Fancy seeing you here again. I didn't think we'd meet like this, but here we are. Chat also says hello. Today, we're doing day 4. Advent, O Camel, if you will. I upload these VODs to YouTube, in case you didn't know. But you probably do, because you're watching this on YouTube. So feel free to like and subscribe. Stick around to the end. C17er has a funny meme that's going to be not going to be a spoiler by the time we're done. But so stick around to the end of the video. Leave a comment. You know what I mean? Like, think about it. I'll reply. Most likely. Okay, let's go. Without any further ado, the gondola takes you up. Strangely, though, the ground... Should we kind of, like... I kind of feel like we should add a little bit of reverb, a little bit of this going on. A little bit... that's maybe too... That's probably too much. Maybe not quite so much of this. And a little bit more... The gondola takes you up. Strangely, though, the ground doesn't seem to be coming with you. That's way too much reverb, isn't it? No. How about this? Oh, now we're talking. That was too much. The gondola takes you up. Strangely, though, the ground doesn't seem to be coming with you. You're not climbing a mountain. As the circle of Snow Island recedes below you, an entire new landmass suddenly appears above you. The gondola carries you to the surface of the new island and lurches into the station. As you exit the gondola, the first thing you notice is that the air here is much warmer than it was on Snow Island. It's also quite humid. Alright, we can't... Is this where the water source is? The next thing you notice is an elf sitting on the floor across the station in what seems to be a pile of colorful square cards. Sounds like you're a game show host. Oh, hello! The elf excitedly runs over to you. How may I be of service? You ask about water sources. I'm not sure. I just operate the gondola lift. That does sound like something we'd have, though. This is the island after all. I bet the gardener would know. He's on a different island, though. The small kind, surrounded by water, not the floating kind. We really need to come up with a better naming scheme. Tell you what, if you can help with something quick, I'll let you borrow my boat, and you can go visit the gardener. I got all these scratch cards as a gift, but I can't figure out what I've won. That's enough of that, though. The elf leads you over to a pile of colorful cards. There you discover dozens of scratch cards. As in, like, yeah, this is the lottery thing, okay? There you discover all with their opaque covering already scratched off. What's up, Dylan? Picking one up, it looks like each card has 2 lists of numbers separated by a vertical bar. A list of winning numbers and then a list of numbers you have. Are these mutually exclusive? It's like Twitch chat. You just got the winning numbers and the rest of you. You organize the information into a table, your puzzle input. As far as the elf has been able to figure out, you have to figure out which of the numbers you have appear in the list. Okay, so there are some mixed in. The first match makes the card worth 1 point, and each match after the first doubles the point value of the card. Okay? So it's not just 2 to the power of the cards that you have, like -1. Right? Yeah, that should work. Okay. So in 41, 48, 83, 86, 17, 83, 86. So here's 1 and 2. We've got these 2 winning as well. 48. Okay, which one is the first? This man, maths. Exactly. In the above example, card 1 has 5 winning numbers. 41, 48, 83, 86. And 17. Yep. Okay. And 8 numbers you have. 83, 86, 6. Okay. Yep. So here's winning numbers and here's numbers I have. This means card 1 is worth 8 points. 1 for the first match, then doubled 3 times. Okay. That's fine. Can they be repeated? Like, what if you have 83 multiple times? For 13 points, take a seat in the large pile of colors. How many points are worth in total? Because I'd like to use a set. I guess we can just check and see. I'll just do sets for the first time. We can do a list if not otherwise, right? If it's in the question and I ask it, it's okay to answer nuts because it's complicated to try and talk to chat and read the question at the same time. So those are acceptable hints. If I say like, hey, did can it have multiple of the same ones? Maybe that one's borderline, but otherwise, like, it's okay because I'm not as focused on reading the question, believe it or not, as I would be if you weren't all here. Do you ever think about how, like, when we have 100 people here, that's like a pretty big room? Okay, cool. All right, then we will use a set to start with, and we'll just change it later if we need to. Let's go inputs 04 test text. Okay. Let's go to day 3 and we'll just do, where do we read this again? Yeah, we'll do this. And let's get this going. Dune exec day 4 profile release. Okay. Oops. All right, sweet. All right, so we can we'll leave this one for now. Parsing always the coolest parts with functional programming. Yeah, that's fair, Squirtle. That's fair. Should we try Angstrom today? Because this one's also pretty easy to do without, but it would be kind of fun to do with Angstrom. All right, we'll do a poll. I'll abide by the results of the poll. Which to implement? Angstrom, which is parsing lib, or splits/regex. And we'll start the poll and we'll ask. I'm a man of the people. I'll give the people what they want. It's a parsing library. It looks like this. Oh no, not this. Do you have a license? I do. I'm one of the few licensed regexers. There's very few, but I'm one of them. Some of these I don't remember how to do, but it should be okay. Don't believe you? regexlicensing.org. I'm pretty sure I'm in here. Licenses? Oh. I'll ask Guy later. Maybe I can get on the list. Maybe I'll get on the list next time. Did day 2 with Angstrom? Yeah, I think I saw that one. Dylan, is nice. I can't do this song. Sorry, chat. All right, well, Angstrom's crushing it, so we'll just we'll go with Angstrom then. Big strings. Okay. Looks like Haskell. That's what I feel like when people type hehehe. That's my best Haskeller laugh as well. That's a good emote. Okay. It won't look like Haskell soon. Where's the do notation? Why don't you have to specify what monadic type this is? Because I still don't know what any of those things mean. I'm too noob. All right. So let's do Angstrom. So what is the test looks like this, right? So we can say like, well, I mean, Parsec is nicer than Angstrom. Oscar? You're really living up to your sub badge right now. Let's explain Angstrom. We'll just do it. We'll show you, okay? So I haven't done this a lot, but I've done it a little. I'm along for the ride. So here's one. We should have one where it just says val string. This should be one. Okay. So what does this do? This is going to match any exact string and returns it. Okay. So let's do an example. We'll do this for right now because we don't care. Let's match game stir, and we'll just say open Angstrom string game. Okay, so this takes some string and returns a string t, or no, we just do like this. This is a string t. So t is kind of like the important type for Angstrom. Okay, and so then we can say let's see, we should have parse until or something like that. Parse string. Parse string runs T on B. Is the parser will receive and end a file after all of it's been consumed. Okay, yeah. We can say like, let input is game. Okay, this is the beginning of this line, or card, sorry. Game, we should say card, game, card. Yeah, like this, okay, right? And then we can call parse string. Consume is all, I guess, or we could say prefix right now because this would be better. We can say card 1 1 2 3 4 5 6, something like this, right? This should take match card and the inputs. This should be some result here, and we can just say match result. Print and line, or we'll do matched failed to match. All right, so let me just make sure that I did this right, and then we'll say sweet. Okay, so this right here is a combinator. Combinator is just basically, like in really simple terms, is a fancy way of saying function that you can combine together with other functions. Okay? That's not like, I wouldn't say that's correct, but that's at least a fine place to start for like how we're thinking about doing this, right? So we have a string that looks like this, and it starts with card, and then this thing says, hey, I want to match all the things that look like card. Okay. So if I put a space at the beginning, this is going to say dog. This didn't match. Nothing looked like card. Like a partial and HTML templating. You can combine them. Exactly right. Like Parsec and Hassel. Yes. Actually, I'm pretty sure they even mention that it is, most of it are derivatives or inspired by Parsec. Okay, right. So this part's not interesting yet. Okay, because this just matches a card. So then we can do, there's some way to make like a digit, right? Is that not included? Number? There's just no, that one doesn't match. Dude, I figured that one would be sort of like built in. Okay, I guess it's not. All right, so let's go like let is digit function 0 to 9 true. Otherwise, false. Okay. All right, so this is just a regular function that asks whether a character is a digit. Okay, right? And we can say something like, I think we can say, we'll just call it digit. Take while. What is the difference between these two? Take while. As long as after turns true and returns the accepted character string, the parser does not fail. If after turns false on the first character, return an empty string. Parser requires that after turn true for at least one character. So this says you gotta have at least one. Okay, nice. I can buy that. I can buy that. Is digit. So this should give us a string t, but we want to turn this into an integer. Pretty sure Dylan did this. I actually have no idea what he did here. This is interesting. I'm just going to yoink this, because I know he just pasted his answer in. Yeah, you can find my dot files. They're not really meant for anybody else to read. Like, they're there. They're not really set up for anybody. Maybe we should do a big stream and redo all my dot files. I'll build the whole thing again. I mean, I'll copy a bunch of stuff, but I'll explain everything. And we'll delete a bunch of stuff I don't use. I don't know. That could be fun. Nice. Okay, cool. So we actually don't even need this. We could just do that if we wanted, but we'll do that here. It's fine. Yeah, that one's also kind of weird. That could also use like a day's work to clean up so other people could use it well. So now we're going to say there's got to be a white space. There's got to be white space, right? White space, space, empty, string. There's no white space one. Okay. Say let white space take while char dot is white space. Nice. Okay, and the squigglies are the function params. I'm man with all these fancy operators. I know, sorry, I copied Dylan's thing. P to F creates a parser that will run P, and if it's successful, runs this. We can get rid of this part, honestly, if you guys want, because it's probably more problems than it's worth for chat. But this just basically says, you can look at the type. It just says, hey, it takes some type and a string, right? And it says, hey, associate this error with if it fails. Okay, so this is basically like saying, what happens if this doesn't work? It does this. Okay, that's what it does. So now we should be a monthly text. Thank you, Bassie. Remember, you all can sub with Prime, believe it or not. Even cooler as well would be to like and subscribe to this channel too. That'd be cool as well. NeoVim key subscription. Let card parse monad result bind. Card parse is gonna be, so we would do like we'll say match card, and then I think this is the operator you do. We say, and then also do this white space, and then also do digit. So what does that return? That just returns a string t as well. What happens if I do not this one? So this is where we have to learn, how do we capture multiple of these values? Runs Q, then discards. That's not what we want to do. All right, let's go back to Angstroms here. How do we capture multiple values in this? I have to accumulate these somehow, right? Or I have to like run. No, that's probably not what we need to do. Maybe Dylan knows offhand. I don't know if Dylan's still here. Oh, nice. Angstrom has a... Oh, sweet. Angstrom actually has some nice let bindings. Ooh, ooh, ooh. Oh, now we're talking. Then we don't even need to have this. We don't even have to have this garbage. Let's put this here. Boop. I will explain. HODL, chat, and or YouTube. HODL, chat, and or YouTube. Okay. We actually don't even need the digit really either, but this is just so that I can show you. And then we can just be done, right? We can just say return digits, something like this. So this should get an int t, and so this can be card parse HODL. Let me just make sure that I'm understanding this correctly, and then we'll be good. Card. Oh right, let white space. Oh yeah. Okay. All right, we got it. We got it. Okay. Let Tim cook. My name's Tim as well, so it works for me as well as Mr. Tim Cook. Okay, so what are we doing here? This let star is really cool because OCaml basically lets you say, hey, how can I say this? This is really similar to like in Rust, where you do like let x is something like this, right? And you have your sort of like try. And then you're right. Okay. AKA do notation, right? Or very similar to like the try stuff in Rust, but you can define your own versions of this. So this let star is from Angstrom. Pretty much you can see the type. What it does is it says, hey, you have your AT. What are you going to do? You're going to call this thing and you're going to return some new BT, and then we're going to return this. So this string card basically takes our input, says, hey, we're going to match on string card. If that doesn't work, we're scuffed, okay? The operator overloading, not really overloading because it's not magic. You can just see what the definition is. But it's similar in some ways, okay? So it just says, okay, we got to match on string card. Then we got to match some white space, right? And then we can get our digits, and then we're going to return them. Now, return is like literally a function here. Creates the parts of all 16 and returns this, right? Okay, so it's like... I think digits, we probably could, I wonder if we just said digits. That probably doesn't work because then you need to actually return out of this. Yeah, that makes, right, of course, because we're inside of, okay. Wait, I don't want to go too far into that part because it's a little bit confusing. We need maybe also a library that I understand better than this one. But, so this says basically card and then some white space and then our digit thing, right? Then digit. What happens if I just do digit? Does this work? Oh, nice. That also works. This makes sense. So this says we're going to get the card, white space, and then a digit. Except, chat, I actually don't care about this digit. But I wanted to show you. Look, here's the matched 1. So if I change this to 4, right, we're going to get matched 4. Because that's the digit that we're matching against. It's like monads. Yes, it's very much like monads, but we don't want to say that and scare away the not functional people, right? Because they've heard that word and it's scary before. Okay. Exactly. Then we should say let star. We should do let star. We don't actually need the digit right now, so that's fine. Let star is string a colon, right? And then now what we need to do is we need to parse these bad boys. We've got this, we got some numbers here, and then a bar, and then some more numbers, okay? So we're looking for, we're gonna need to somehow like fold. There's gotta be like a fold thing, right? Or is there really, there's really no fold? What would this be, iter? I'm not sure what I'm looking, take while. I guess I can keep take while. Let's look at Dylan's here. Oh, is it many? Whoops. Many P I0. Yep. That's how we get to a list. Nice. That is what we're looking for. Is there a rule that we can't use Copilot or ChatGPT? No, you can. They ask that you don't do that if you're trying to solve in the first like 10 or 15 minutes or whatever, if you're like one of the speed racers. But you're totally fine too. Set by runs P ooh. Yep. Interstring runs of S in between. So we want set by. So we want basically sep by 1, because we know that we need at least one white space, because this is the first one is the one we don't care about, white space and digit. So now we should get a list of numbers. Let's go. List head. We'll just get the first one to make sure that we're parsing this right. That's fine. Digit. Parse one or more digits. Count while. Separated by white. Oh, I got to do this probably. Nice. Match 12. So that's our first number. Yeah, that's okay. I don't want it to just fill it for me. No more times have I called about doing something. Yeah. It's fine. It's just not really what I want to do. Right? So then we should say, so this is actually let star winning is this. And then we should see some white space. Some string bar, right? Some more white space. And then this is, instead of winning, these are, hours or something like that. And then we want to return winning and hours like this. So now we should have an int list and an int list. Nice. We could call this, what did we call these? I guess we could call them type card is equal to theirs, which is an int list, or we'll say winning int list and hours int list, just so that's a little bit easier. I feel like it's a little bit easier if we do that, right? Winning hours like this, right? And then we should be able to do deriving show. Okay. And then we should be able to do this. An A, and then let's just do res. Nice. There we go. Cool. So 12 and 13 and 56. They call it pool. Our name hints aloud. Pool is a good name for that variable. Sure. I did. That's probably fine too. Angstrom is one of the coolest things I played with. It's very cool, right? So you can literally just walk through. You can just see exactly how we solved it, right? In fact, this would probably be easier to just write it as white space, digit, string, and just get rid of this, right? Because then we can just discard all of those. We really don't care. And then you could do the same thing here, right? With string and white space, and then do this, right? In fact, what you could do is we could say let W string is equal to, where do we have this? We say white space, string, white space, right? Right. Like this, right? So then you could just do W string and this, right? Because this is a little bit nicer as well. Like, this kind of idea is pretty cool, right? Curious on runtime performance of what? Angstrom? It's fast. Very fast. I'm going to look at source of set by 1. Fix, lift to, cons, p, s, this, that, this, the return that, this. So it's pretty simple. Honestly, if you're not really getting that on the first sort of... Like, if you haven't gotten it by now, I kind of think... Probably not even worth really, like, looking at it anymore. Kind of embarrassing. Blazingly fast. Okay, so this gets our cards, or whatever you want to call it, a pool or whatever. That's fine. So what was the problem again? If you don't understand that line, maybe programming isn't for you. Exactly. Exactly. Thank you. If programming isn't for you, consider subscribing at TeachDV Daily. Okay. So then we're just looking for all of these that are on this side, right? So can I not just do... So we have this card here. This is let parse line. Line is literally just this match with okay res haha using exceptions, get wrecked Haskell. All right. So meanwhile, boom. Let's check the first line, right? So like let card is equal to parse line of list head lines, and then we'll just do line 1 just to make sure we're still doing this right. You know what I'm saying? Ha, exceptions get wrecked, Haskell. Okay. We'll just go back up to here. Nothing to see here. Parse string, error. Get wrecked, Haskell, error. The variant type is expected to have card string. There is no constructor, error. What did I do wrong here? Oh, error. Duh. Okay, that makes sense. String. Totally good call. 04 test. Okay, so we were right the whole time. We don't need it. We can still say get wrecked Haskell. Okay, cool. So then let's just do that's not Rust. You're right, that's not Rust. So let's do like let left is I think we need to make let module int set is we just want to do set dot make, I think, right? And then module int should work, or just int, I think, right? That should work. Sweet. We say int set dot of list card dot winning, right? This should be winning, and then let hours is hours, and then we just want to do it's Visual Basic. Exactly. Hi, Tachi. Welcome. Okay, so like take this information we made and use it in the next. What are you saying for sewing where? Wait, so in just means we're in the same function? Kind of. It like it creates sort of like, you should think about it as, it's not exactly that it's creating a new scope, but it's like saving variables for later, more or less. Except they're really identifiers. They're not variables. Variables don't exist in OCaml. Actually, variables don't exist in OCaml. Union list. Is it not you? What am I looking? Oh, is it not union? Does this not have union? Does it not have like union or anything? Int set t intersection, is that what I'm looking for? Compare empty equals filter map of array. I guess we could just do filter map, right? It just seems like isn't, but I don't see it here. Let's just make sure that my LSP isn't getting confused. Because why can't it find the definition of this? It's like, that's pretty weird. It's just enter? This is core, so that's the confusing part. Is I would have thought for sure that this would have core. Okay, I don't think I understand how it works. I think it does, and that's all I really want. You can basically, if you see an in, you can just think of it as semicolon. Like it's literally like letting lines equals this. Like that's basically what we're doing. Am I not clicking this correctly? Compare, make. I mean, I shouldn't. Honestly, we can just write it like this. Like we can just do this filter map. Winning hours f. Function win. Int set dot mem hours win. Right, something like this. Is mem not? I must have done something wrong because this seems not right at all. This doesn't seem right at all. Compare equal empty. It does not how to, this can't be right. Yeah, this doesn't even have contain. Like this doesn't seem right at all. I must have done something wrong here. All right, we can just, we'll just go, let's just do this. Union of list. I don't know. This seems weird. All right. So this should have, this has of list. Okay. Let's do, this has to have enter, right? Yeah. Okay. I don't know. So I must have done something wrong in that. I don't know. Or like something's weird with this core one, or I should have done something different. I don't get it. I don't know how that doesn't have any set operations. Yeah, I'm just using the standard lib one now. So that just seems weird. So then we want to do basically two. I don't even know what the power is. Power? Math? Pow? I don't know what power of OCaml operator. I don't think I've ever written exponents. Int.pow. Okay. I'm assuming 2 to int set dot cardinal intersect -1. I don't know. Thingy 1. Yeah, we can do this. Thingy 1 8. So let's see. Is this what we got for the first line? Okay, I don't know. That seemed standard lib has it. We'll just do int pow. I don't know. Okay, so this works. So then we just want to basically do, instead of just doing this for each line, right? This is basically like we can do list fold lines that are getting added together, right? 2 2 2. Okay, yep. So they get added. Init is 0. F is ACK and line. What are we gonna do? We're just gonna do this to line, and then we don't need that. We're gonna get each of these. We don't need to do this either. We can just take this and we'll say let's I don't know, score or something like that is this, and then we can do match we'll say this 0, then we're just gonna do ACK. Otherwise we're gonna do cardinal ACK plus cardinal All right, so what did we do? Let's see if we did this part right so far. Lines. So some line busted. Uh-oh. Digit. Parse 1 or more. Count while 1. Oh, wait. Oh, I think I know. I've got an idea. Yep. Classic W string. That's what I should have done. There we go. 13. Okay, cool. So we can just try this, I think, on the real one now. I think that's probably good. And that was cool. We got to try it with Angstrom, too, which is fun. That's the right answer. Nice. Okay. Just to reiterate, what did we do here? I guess I didn't really explain this part very much. This is just... You get the list on the left side. You get the list on the right side. You just intersect them. If there's no intersection, then it's no points, right? And if it's anything else, then it's 2 minus that power, right? Because like if you have one number is worth 1, right? So 2 to the 0 is 1. 2 to the 1 is 2. 2 to, right? So you just do that, right? Why is it so fast? I don't understand nothing about FP. Well, I mean, we didn't have to do it. This is all like just O of the lines. This is really quick stuff. The trick that you might not do is turn them into sets and then intersect them. If you try and check, is this one in any of these, or is this one in any of these, or is this one in any of these? That's worse time performance. I would be surprised if it took a long time though, because like they're just not that, the combination is not that big. Like it should probably be fast no matter what you pick for part 1. Any questions before we go to the next section? Any questions, chat? Oh, we'll put the code back up. So I did, but yeah, it's still pretty fast. Shouldn't be slow to even just use straight list inclusion. Right, that's what I'm saying. Can AOC? Yes. AOC answers are pretty much always different. Yeah, like you could do this with loops. I just wanted to write it this way, and I wanted to try Angstrom. All right, cool. They have different inputs, right? So it's like they'll be different answers. You can't just type mine in. Okay, so no questions. I think we're good here. Just as you're about to report your findings to the elf, one of you realize the rules have actually been printed on the back of every card this time. There's no such thing as points. Toss it away. Yo, Griff, what up? Do the next one with a class and all loops. Never. We're going to keep up the Okameling in normal Okamel style. Instead, scratch cards only cause you to win more scratch cards equal to the number of winning numbers you have. Wait, so instead, scratch cards only cause you to win more scratch cards equal to the number of winning numbers you have. Specifically, you win copies of the scratch cards below the winning card equal to the number of matches. So if a card 10 were to have 5 matching numbers, you would win 1 copy each of 11, 12, 13, 14, 15. Do you manage to avoid spoilers? Yeah. I just don't. How do you get them spoiled? I just don't read the solution or go places where it would get spoiled. Copies of scratch cards are scored like normal scratch cards and have the same card number as the card they copied. So if you win a copy of card of 10 as 5 matching numbers, you would then win a copy of the same cards that the original card 10 won. Cards 11, 12, 13, 14, 15. This process repeats until none of the copies cause you to win any more cards. Cards will never make you win a copy. Okay. Card 1 has 4 matching numbers. So you win each of the next 4. 1, 2, 3, 4. Card 2 has matching numbers. So you win 1 copy of 3 and 4. Your copy of card 2 also wins 1 copy each of 3 and 4. Your 4 instances of card 3, 1 original and 3 copies, have 2 matching numbers. So you win 4 copies each of card 4 and 5. Your 8 instances of card 4, 1 original, 7 copies, have 1 matching number. So you win 8 copies of card 5. We already parsed them. That part's easy. If you were there when Prime was doing it, yes. No. I specifically don't watch Primes unless I've already done it. Yes. Prime's the only other person that I would watch solve anyways, though. Your 1 instance of card 6, 1 original, has no matching numbers and wins no more cards. Once all of the original's copies in process, you end up with 1 card 1, 2 of 2, 4 of 3, 8 of 4, 14 of 5. Total, example, you have 30. Interesting. Okay. So let me just try. By the way, I think that JS core sets are meant to be used with FCM operators. So you don't create a new module and instead do set of list module int. Oh, you're right, Oscar. You're right. I think I have seen that before. Okay. Prime is the only stream teachers watch, obviously, because I don't do AOC. Got him. Okay, so card 1 wins, so we get 4 wins. Okay, so what I'm thinking, we never need to go backwards, right? And we never need to process after the end. So we could keep track of what number we're on, and we can just basically count. We can kind of keep a tally. Probably a hash table, because maybe it'll be easier mutable. Maybe it won't be. We could probably just do it with the set and pass it and accumulate it. That's probably better. That's more okay anyway. So we do this one, and then basically we'll tick up 2, 3, 4, 5. So we'll basically say 2's already got 1, 3's got 1, 4's got 1, 5's got 1 that we need to do, right? Why not regex? You can do it with regex. I just did it with parser combinator library because we wanted to try it. Nightshade, just check your input. I don't know. I don't remember. So then I win on card 1. So here's what I'm thinking. Chat. Okay, here's what I'm thinking. If we run through the list one time, we can figure out the score of each line. Right, so we would score this one as 5. And then this one would be 2, right? I don't remember what they score are. We can go back to here. This one's worth 4, right? This one's 2 and 2 and 1, right? Hey, see, Griff. And then this one has 0 and this one is 0. So then what you do is you say 1, since it wins 4, you can just say card 2 is 1, and then you can just multiply them by how many times they get counted, I think. Like, I think I would do it in 2 passes because it seems easier. Right? You do 1 pass, you get all the counts. Which, by the way, chat, we already have that. That's right here. That's this. Right? So then now I know what the value is on each one, and I can just figure out what the rest of them are, right? I think so. I think so. Let's just try. I don't know that I'm explaining that super well, but maybe my answer will help explain. So this is basically let scores is so this should be, we want to do a list, and we want to do this ACK, basically, right? I think this is reversed, right? Won't this be reversed? So let's go back to, instead of doing prod, let's do test. And then let's go ahead and we'll just print off the score list iter I scores F IDX. We can just say something like this. Right? 4 2 2 1 0 0. Right? So this is a good start right here, right? So this is our list of scores. We're looking for all the ones that have more than 1. Now, those are winners, right? So then what do we want to do? We want to get basically like the count of how many times there, or we want to get their like multipliers. Right? So then what are we going to do for that? What I would do is the simple way, at least that I'm thinking of, is I would do let multipliers or something like this, is array create length is list length lines, and then the value is 0 in this, right? So this should be a multiplier. So then we should be able to do this array iter multipliers, and then we should get the same. We should get 0 0 0 because we haven't done anything here, right? So now what are we gonna do? List iter scores f function idx and score, right? So then what are we going to do? We're going to do list range. Maybe we can do sequence range. Is there no like range? I don't know. That's fine. We'll just do list. List range. And we'll do 0 to the score. Because maybe we need to do this. F? Did I just do an F? No, I don't think so. It doesn't look like it dropped any frames. So what? Let me just read the problem again. So it's like 4 matching cards. So you win. So if it's 0, we're not gonna add anything. So then I can do 1 to the number, right? Maybe can I just do 1 to score? So we have 4. That's gonna go 1, 2, 3. No, we need to do. Card 2 also So if it has 0, it's not going to do anything. I'm trying to think what's a nice way to write this. Why are you using dead programming? Ah, sorry. Sorry, I'm not even compiling to Melange. Embarrassing. Let's do this. Let's do this way, though. Let's just go if score greater than 0, then we're going to do this. List range to 0 to this. So then let's go list iter. We got to do something for each of these. So we can say fun offset. What are we going to do? We're going to do multipliers. I forgot. Can I do like offset plus IDX plus equals 1? I don't remember how to. What's my syntax for arrays? Oh my goodness. Oh my goodness. What's array? Oh my. I'm embarrassed because Antonio's here now. Antonio, just tell me and put me out of my misery. All right. Okay. Whoops. Is equal to this plus 1. Oh, we also have to do our own because it counts. So 0 should be counted once. We should count 2 twice. Let's make sure that we got this right. Does it tell us how many times? 2. Oh, no, because then we... Oh, tricky. This is AOC. Jersey, what's up? No, this part's not right because these need to get multiplied by themselves. Okay, we have to do something different for ourselves, right? Which is pretty much we multiply it by 2. No, how would this work? So card 4 has 1 matching number. This one has 1 copy from each of these. So 1 for this, 2 instances of card 2. So when card 2 wins, we play this twice. We're going to play this twice. Ooh, got it. Got it. Maybe. List range 0. Or no, we can just do this. We can say, I think this is going to be... IDX is going to be what? IDX plus 1. Oh, right. I got to do this. So first we're going to add 1. Add 1 because we won. Right? And then add the rest of them. But then this is actually whatever this value is. Hopefully. 1, 2, 4, 6. Dang, we didn't get it. Is it multiplied by this? No, that can't be right because then we're not going to count it. Ah, shoot. Let me think. Because, so, all right. So we do 1 here, right? So in this case, then we're going to add 1 to each of them, right? 1. So you think about walking through here. Okay, cool. So we need to add 1 for ourselves because that's still a winning number, right? We're going to end up with 2 instances of 1 because that one also wins, right? When we go here, we're going to get 1, 1, 1, 1, 1. Maybe we should print off each of the iteration. Score determines subsequent multipliers. Range 1 to score. I'm using score right here. Ooh, do I need to do plus 1 to this? I probably do. 1, 2, 4, 8, 13. 1, 2, 4, 8, 14. The heck? Oh, what did I... Oh, no. Oh, no, chat. Oh, no. What did we do? How did we get this? One, two, four, eight. And we also didn't get the other card here. So we have... Oh, this... We should just do... Just so you get the same things here. All right, so 1, 2, 4, 8, 13. Well, I didn't think about getting it right the first time. That's what I'm trying. I don't think my logic is good though. So this one should count 1, 2. So 1, 1, 1, 1. Something like this, right? 5 should also have one. That's at least one per card. Oh, do you always win the next 4 matching numbers? So you win 1 copy of each of the next 4 cards. Ooh, is that what I'm not doing right? Does this need to be +2? 1, 2, 4, 8, 15, 13. That doesn't seem right. Line 73. If card A wins with 2 score, it wins card B and card C. But if you had 5 card A, that becomes 5x card B and 5x card C, which then to be scratched. Right, that's what I'm doing. I'm walking it forward. So you have to have at least one of all of them, no matter what. No. Shouldn't all the cards count, even losing cards? Do they? You end up with a 1 instance of card 1. Oh, are we not counting Oh! How many total scratch cards? Thank you, chat. Okay, so I misunderstood. It's not which ones win, it's just the count of all of them. This actually makes the problem a lot simpler. So we don't have to do this. 1, 2, 4, 8, 14, 1. Got it. I just misunderstood the question. Classic. Yep, that makes sense. The base case is when you get to cards that stop winning. Yep. It is hard to read and talk to chat. I will say that. That's an acceptable hint. I'll allow it, chat. I'll allow it this time. Process all of the original cards and copy scratch cards until no more scratch cards are won. I don't think I handle that correctly right now, though. Like, I think if I put this in first, I'm going to lose. So I'm pretty sure I need to do fold until. Because what if it stops in the middle? I don't think we did that. 0. Then we're going to do, is it stop? Is that what this is? If F return, so we would say stop, act. Otherwise, cardinal. What is this? This returns. Oh, finish, right. So then we say finish, fun. That can't be right? Does this work? Okay, nice. So this should make it, what is 0? So if there's no winning numbers, what it says is go through all of these until no more scratch cards are won. Right? Won't that mean when I get the first one that fails? Or did I misunderstand? No, when they fail, just keep processing. Oh. I'm misreading this as well. Your one instance of card 6, one original, has no matching numbers and wins no more cards. To win a copy until none of the copies cause you to win any more cards. Okay. I'll just... Oh, I see what you're saying. I gotcha. Okay. I thought it was adding a nice trick in the mix here. You know what I mean? I thought they were adding a nice little trick in the mix for me. Oh wait, and then I need to add them all up, right? I guess I didn't sum them before. Can I not do this? Reduce? Oh, whoops. There we go, right? All right. I guess we should make sure that this actually... Ah, whatever. We'll just paste it in and see. What do you mean have a nice sum? This is a nice sum. Reduce with plus. Okay. First try with no test. Nice. I know, I was thinking maybe I should have gone back and made sure, but nah, I'm confident. OCaml won't let me down. Okay, I think we can also get rid of this if score is greater than 1, because we're still going to count those. Is that the same value we just got, right? Right, that's the same value. Yeah, because we don't need to do that anymore, which is nice. Oh, I lost it. Yeah, I'm pretty sure. Yeah, that's the same. So that's nice. That makes it even prettier, chat. Yeah, this seems pretty good. I like this solution. What would be the nicer way to do this? You could move this. So the reason they continue to no workers being ones because there's a more naive strategy to put the cards you win at the end of your list of cards you already own. Oh, I see. Yeah, that makes sense, Tony. I see what you're saying. Yep. I see what you're saying. Let's do this. We can do int set t. Oh, is there no, like, there's no pretty printing inside of this? What? I guess we don't need to do this anymore because we're not even going to show them anymore. Okay, so then we don't have to do this or this, right? We can just say card winning, card hours, which is nice. And then we can do the same thing here. Like, there's no reason not to just parse these into insets if that's all we're going to do with them, right? It was simply harder. Definitely tried to do it with recursion. Oh, nice. Okay. Here, we'll put this over here. Trim, enumerate, fold, vec of 1. We got something cute under the size, IDX and L. Split, blah, blah. Okay, so we get the numbers and we get the counts. Winning numbers contains this. Sure. Okay. If the count... I guess you don't even... That's true. I guess you don't even need to turn them into numbers, right? So that's nice. Oh, shoot. Hey, sorry, YouTube. If you're still here, I guess you stayed a little extra. Whatever. That's the end of the video. Subscribe. Bye.